Yeah, what up, guys? So today we're going to work on next permutation, number 31 from LeetCode. So LeetCode medium problem. This one's actually pretty rough on the explanation, but I'll trim it down and make it a bit easier to understand here. So let's go ahead and get right into it. So it says a permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, 1, 2, 3, the following are permutations of array 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. And this problem before did not give this much of a description, but honestly, I think it was probably better before because this description of me kind of just makes things more confusing, but we'll read the rest of it and I'll kind of explain. If all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows in the sorted container. Such arrangement is not possible. The array must be rearranged as the lowest possible order, i.e. sorted in ascending order. For example, the next permutation of 1, 2, 3 is 1, 3, 2. 2, 3, 1, 1, 3, 1, 2. And okay, here's the edge case. While the next permutation of 3, 2, 1 is 1, 2, 3 because 3, 2, 1 does not have a lexicographical larger rearrangement. Given integer array nums, find the permutation of nums. And this also must be in place and only use constant memory. Okay, so kind of a hard problem. My first thing that I would say for this, when you're talking about lexicographical order and what's the next greater value, like let's say we're doing the alphabet, the first one we have like A, the next lexicographical largest value is going to be B. Well, let's take this example of 1, 2, 3. So what it means is given these three numbers, let's say that 1, 2, 3 is actually like 123, the value itself. So what's the next largest value? It's 124, right? But we don't have a 4 given from our values. We only have three values, 1, 2, and 3. So what's the next largest value we can make with those three numbers, as that's what we have? Next largest value we can make with those three numbers is going to be 1, 3, 2, or 132. Okay, and then from there, what can we make next? Next we can make 213, 2, 3, or 213, and then from there we can make what? 2, 2, 3, 1, and then from there we can make 3, 1, 2, right? Yeah, and then 3, 2, 1. Okay, so that's how that works. We're just looking for, given the numbers that we have, what we're given, what's the next largest number we can create. Okay, so how can we do that? There's a lot of different ways we can do that, but how I see it is, on initial thoughts, was like, okay, so let's look at an example here. 1, 2, 3. And before we get into this, remember that if we're at the largest lexicographical permutation that we have, which for this instance is 321, then there's nowhere larger to go, so the next one would be going back to the start. So we got to remember that as well. 1, 2, 3. And if you notice here, actually, 3, 2, 1 going to 1, 2, 3 is actually just 3, 2, 1 reversed. So there's a little hint for you. But looking at this, going back, how do we figure out what our next permutation is when we're going to tell it to a computer? If I was going to tell this to a computer, what I would think is, let's figure out how we know what to switch. And we know for this first one, right, that it's going to be 1, 3, 2 is the next one. So how do we get 1, 3, 2? Well, something kind of immediately comes to mind is if we're scanning from the right and we figure that we find a value that is less than the one we're looking at. So 2 is less than 3, then we switch them, which actually works out. So we switch these. Okay, cool. Now, our next permutation, how do we find that? Okay, so we look, and now we're looking at 1, and then we switch 1 and 3, then that gives us 3, 1, 2 for our next. Well, that's not going to work because we don't go from 1, 3, 2 to 3, 1, 2. It'd actually be 2, 1, 3 would be our next, right? That'd be our real answer. Okay. So how do we get 2, 1, 3 instead of 3, 1, 2? So say our first intuition here is that we have we switch the values as they're greater, but we also need something else because we need to get this answer, not this. Because if we just switch the values, we're going to get this answer. So let's go back to this step. We evaluate, we see this. Now, for our switch, instead what we can do is actually switch the lowest value on the right side that is greater than the current value that we're looking at. And what I mean by that is, so we know that our values here are going to be sorted in descending order to the right of our pivot. Say 1 is our pivot. Okay, so we know these values are in descending order. So in most cases, this value is going to be the furthest right, but we can continue on until we find a value that is this. For this case, we would switch this one, but there's going to be larger subsets. But here's an example. So let's go back to this one. We got our first permutation right. And then instead of swapping 3, once we find that 1 is less than 3, we're going to look at 3 and 2. And when we look at 3 and 2, okay, we need to switch 1 with one of these two values. So what if we did a second loop here, like a J, and J just continues until J finds a value that is greater than our pivot, the first value that we can find that's greater. And we know that the first value that we can find that's greater than our pivot is going to be the correct value because we're in descending order, 3, 2, 1. Just like on the right side we have this, it would be 4, 3, 2, 1. Like that, it's going to be in that order. So we're going to skip this one and then we'll find this one each time, whatever the largest value is. So instead of switching 3 here, we actually switch the 2, which gives us 2, 1, 3. Okay, perfect. Okay, so now we have 1, 2, 3, 1, 3, 2, 2, 1, 3. And now another thing we can do, now that we have 2, 1, 3, the next value that we're going to have is 2, 3, 1. And how can we find 2, 3, 1? So we sort the values, or we reverse the order of these values that are on the right side. So now we have 3 and 1 on the right side, and we reverse their order, and that'll give us 2. Sorry, we got 1, 3 here because we switched that way. Now we have 2, 1, 3, which was our answer. Now we reverse the values to the right of our pivot, which is 2 now, and we get 2, 3, 1. Okay, so that's our next. Okay, so we saw a lot of examples here, but how do we actually implement that? Okay, so let's talk about intuition here in this block, and then we'll get into some coding now that we've went through a couple examples. And hopefully, if the examples didn't clear things up super great, this intuition block accompanied by the code will. So we're going to traverse knobs from right to left, like we mentioned. Once we find a pivot, what is a pivot? The value in which our current value is less than the value to its right. Now, once we find a pivot, once we find the pivot, we will reverse, or we will swap the values and reverse the remaining array. All right. So that's kind of what we're thinking here. So let's try that and see how that goes. Now let's do nums.length. And since we're evaluating, actually we'll do -2 since we're evaluating from nums and then its previous value. We'll say we'll call this I actually, and we'll I is greater than or equal to 0, and nums of I is greater than or equal to some I plus 1, so we're doing our evaluation. We do I minus minus. Okay, so now we found our pivot. This is the logic to find the pivot. So while I is greater than or equal to I plus 1, we do I minus minus. So for example, just to keep things clear here, 1, 2, 3. At this case, let's say I is this, and I is greater than or equal to I plus 1. It's not. 2 is less than 3. So this immediately I is going to become our pivot because we're not going to decrease I. So now we have at num sub I is 2, so we have our value here. So we need to do our swap. Okay, so for our swap, we need to first check that I is greater than or equal to 0, because this value could make it go to -1, which will. The reason that we end up doing -1 as a possibility here is because if we end up having that edge case of 3, 2, 1, and we need to go back to the beginning, we're just going to reverse the entire array. So this is kind of our edge case for that. But for now, we're going to evaluate for this first case that this is true. So we need to do our swap. So our swap isn't just as easy as swapping the values, because we saw that earlier. We had that issue with swapping the values. So we need to find, in every case, that right side subset. So if we use the right side, how can we calculate the right side? We want to do another int, like I was saying, like j. So we'll start from all the way on the right. While num sub j is less than num sub I, j minus minus. Okay, so these values are going to be increasing as we go. And then now we will have, after this while loop, the value where j is greater than. So we'll do our swap here. And temp equals num sub I. And then we'll say num sub I equal to num sub j. And then num sub j is equal to temp. Okay, so we've done our switch here. Now the only thing that we have left to do is to reverse the array, but how do we, and not the entire array, but reverse that right side. So how can we do that? Okay, so outside of this, we'll do our reverse. So we'll just call it reverse, and we'll do nums I plus 1 and nums.length -1. So this is going to be our left, our right, and then we'll pass the actual value. So let's make this into a new function as well. With void reverse. And we'll talk about its values that it'll take in. Input parameters. Okay. So we'll do kind of pretty much the same thing that we did earlier. So while left is less than right here, and temp equals num sub left equal to num sub right equal to temp. Okay. Oh, and we also want to do right. Okay, so now we have found our pivot value. We have searched through the right side for the least greater value that we can find that is greater than our pivot. We've swapped them, and then we've swapped the rest of the array. We've also handled the edge case of where it's at the end and there's no more permutations by ensuring that we can go to -1 through this while loop. And if the value is -1, we'll skip all of our swap logic and we'll just immediately go to the reversal. All right, so, and we didn't end up using any additional data structures where we had to store, length of nums or any in values, so we're at O1 space. We also, at worst case, are visiting every item in nums once, so we're at linear time complexity. So let's see if this works. Oh, we need to do, yeah, we need to do it. Actually, right here, we need to do an if I is greater than or equal to 0, not less than or equal to 0. And likewise, we also need to do equal to, because if these are equal, then we'll have this issue. Okay, so let's try now. Okay, accepted. Yeah, so that is next permutation. This one is kind of a hard problem, so it took me a while to get it, even tripping up a bit. So best of luck to you guys. If you like this explanation, feel free to leave a comment, drop a like, subscribe, and I'll see you guys next time.